Introducing Driving Energy Efficiency for Sustainability Manufacturing. Hi, we are from Asia Pacific University and here to showcase our photogrammetry digital twin model for machine monitoring and maintenance predicting. Our aim and objectives of this project are shown as below. For the aim is to improve the monitoring and controlling system for machines' energy efficiency. There are three objectives. The first one is to design a sensor measurement prototype to collect data for prediction using linear regressions, and to develop a digital twin model, which is the monitoring system which allow users to have a better visualization. And the last one is to evaluate the efficiency of the machine based on temperature data. We are addressing several challenges within the car industry, including energy wastage, untimely maintenance, and the inability to monitor remotely. By overcoming this issue, we aim to contribute to the achievement of UN SDG 8 and 9. This, in turn, will foster economic growth in Malaysia and enhance the country's industry innovation and infrastructure as we transition towards the digital era.
Hi, my name is Karen and I'll start by explaining the design process of our project. To achieve the goal of our project, predictive analysis will be performed by collecting vibration data using ADXL335 accelerometer. A linear regression model will then be applied to perform the predictive maintenance on the machine to allow for on-time maintenance. Then, temperature-based efficiency monitoring using thermocouples will be implemented on the machine in order to monitor the real-time coefficient of performance or COP of the air conditioner, which tells the user the ratio of cooling capacity to power input of the system. After that, a detailed 3D model of the machine will be generated by capturing images of the air conditioner with phone camera using photogrammetry technology. Lastly, all of the parts will then be assembled with the collected data sent into Azure Digital Twin to allow for monitoring and prediction of the system remotely. For our final product and testing, the first image shows our prototype circuit for vibration analysis of the compressor of the air conditioner. The second image shows the prototype circuit for COP monitoring of the system with thermocouples. The third image shows the 3D photogrammetry model of the system. And lastly, all of the components will then be integrated together to send the collected data to the digital twin for real-time monitoring and prediction, as can be seen in the middle here. All in all, predictive maintenance was able to be applied on the air conditioner system using vibration analysis with linear regression prediction model. Efficiency monitoring of the system was performed by collecting temperature data and analyzing the COP value obtained to understand the cooling capacity and power consumption of the system. 3D modeling of the air conditioner unit was done using photogrammetry technology to create a highly accurate and detailed representation of the system's components. Finally, the gathered data was transmitted to digital twin, enabling remote real-time monitoring and predictive maintenance with 3D view of the air conditioner unit. In conclusion, our prototype is able to allow for predictive maintenance, efficiency monitoring, as well as remote real-time monitoring of the system, which will provide cost and energy savings to the end user. That is all for our presentation. Thank you for watching.
So this is the Group 8 field test. As you can see, this is the aircon prototype, which is in the level 1 lab. And this is the design behind all the connections of the piping. At first, you can see this is a compressor, and you can listen to the sound, and then it's a shaking compressor. And you can see the compressor is attached, mounted with the ADSL vibration meter, which is connected to the Arduino Nano 33 IoT. This Arduino Nano 33 IoT is come with the Wi-Fi module, which will send the data to Azure IoT Hub. And also, there's 4 different thermocouples. They will collect 4 different temperature values to the Arduino Nano 33 IoT and send to the Azure IoT Hub. So currently this prototype is on, it's working. As you can see the aircon, there's some air blowing here, and here is the data from Python. The Arduino Nano 33 i3 will send the data to Python for calculating the COP value and the RMS value for the vibrations, and it will generate a linear regression data to indicate the compression health. And then you can see the real-time COP monitoring here. And this all data will be sent to the Azure IoT Hub. So this is a stream job query which will display all the data from Azure IoT Hub. As you can see, this is the first one. You can see this is COP value, and then EWB, EDB, TOut, TIN, RS value, and all is just time. So the field test is success. The data is real-time monitoring, and I show you the digital twin. So after looking at here, let's see how the Azure IoT Hub looks like. So from here, this is my Azure IoT Hub I created, and yeah, it's loading. As you can see here, you see all the data, how many data sent by today. We're using the free tier version with only 8,000 message can send for one IoT devices. As you can see, all the data is sending a lot right now. And now let's see how the digital looks like. So this is the digital twin model. As you can see, it's showing all the compressor, condenser, and reverter in the good conditions, and this is all the data for it. And I can move around for to see the digital model from here. As you can see, I can take this, and then I can move around for the 3D model. Yeah, and then I can see the value for both of them. Yes, so this is a success for the field test. Thank you so much.